It's important to distinguish the process of solving a rational equation from the process of adding two rational expressions. And it's easy to get confused because the steps are somewhat similar. So let's take a look at a rational equation that we've seen before. Let's suppose we wanted to solve this rational equation. What would our steps be? Now, we could add and cross multiply, but as we've seen, that's going to make this harder than it needs to be. So let's instead solve just by getting rid of these denominators. What are the steps? Our first step will be to find the least common denominator. Remember, 1 is just 1 over 1. Well, both of these denominators are prime. There's no factoring to do. So in this case, my LCD will be just x minus 1 times x plus 1. The second step, you should be aware, only is available to us if we're solving an equation. In the second step, we are going to multiply both sides of the equation by the LCD. Notice that this changes the value of both sides of the equation. We aren't allowed to do this when we're simplifying an expression and we want to keep the value the same throughout. But here we're solving an equation. We're allowed to multiply both sides of the equation by the same thing. Note the parentheses. Are those required? Boy, howdy, are they required. Here we see addition. That means to multiply this sum by this rational expression, we will need to distribute. What will we have? Well, on the left-hand side, notice this is just one rational expression. We can go ahead and multiply. Here, we'll multiply our first rational expression and our second rational expression, both by this expression. Now we're ready to simplify both sides, and when we do, we should no longer have rational expressions. We should just have polynomials. Let's see. Well, we can cancel out an x minus 1. In this rational expression, we can cancel out an x plus 1. Notice, we've canceled everything that appears in a denominator, so we have been successful. We have, well, what's left here is 6x plus 1. What's left here is 8x minus 1. And what's left here is x plus 1 times x minus 1. All right, now we can go ahead and solve. So distributing 6x plus 6 equals 8x minus 8 plus, what do we have here? When we multiply this out, we're going to get a difference of squares. Now we can do the addition over here, collect all of the terms on one side. I'm going to collect them over here because I happen to like positive leading terms. Now we need to factor this right-hand side. We'll need two numbers whose product is negative 15 and whose sum is positive 2. I think that 5 and negative 3 will do that for us. This row, my greatest common factor is x. Here it's negative 3. Here it's x. And here it's positive 5. So x is 3 or x is negative 5. And then there's one more step. Confirm that we did not multiply by 0. Here we multiplied by x plus 1 times x minus 1. If I plug in x is 3, this is not 0. If I plug in x is negative 5, this is not 0. So we have no extraneous solutions here. These are both true solutions. All right, let's see another example, and then I'll have you try one. Let's suppose that we want to solve this rational equation. 2 over x squared minus 1 equals negative 3 over 7x plus 7. First, we're going to want to find our least common denominator. In order to do that, we're going to need to factor our denominators. So, x squared minus 1, that's a difference of squares. It factors as x plus 1 times x minus 1. 7x plus 7, well, the best I can do is factor out the common 7. So my LCD will be, I need an x plus 1 and an x minus 1. I also need a 7 and an x plus 1, but I already have that. My least common denominator will be x plus 1 times x minus 1 times 7, which I think looks prettier if I write it as 7 times x plus 1 times x minus 1. Coefficients in front looks nicer. All right. Now this is the step that I can only do because I'm solving an equation. I'm going to multiply both sides by my least common denominator. I'll multiply the left-hand side by my least common denominator and my right-hand side by my least common denominator. Noticing that both sides have only one term, I can just go ahead and multiply. And now I'm ready to cancel. Here I see x plus 1 is a common factor in this rational expression, as is x minus 1. Here I see 7 in common and x plus 1 in common. What does that leave me with? This rational expression becomes 7 times 2. This rational expression becomes negative 3 times x minus 1. Oh, this is going to be easy. This is linear. I get 14 is negative 3x plus 3. Subtracting 3 on both sides, I get 11 is negative 3x. And dividing both sides by negative 3, I'll get x is negative 11 thirds. Before I say that this is actually the solution, I need to notice that 7, x plus 1, x minus 1, well, 7 is never 0. Negative 11 thirds plus 1 is not 0. Negative 11 thirds minus 1 is not 0. So I did not multiply by 0. All right, I'm going to give you one of these to try now. Solve the rational equation 1 minus 3 over x minus 2 equals negative 12 over x squared minus 4. Pause the video and try this now. All right, first we need to find the LCD. Well, x minus 2 is prime. X squared minus 4 factors as a difference of squares. X minus 2 times x plus 2. So my LCD, it's pretty easy to see, is going to be x minus 2 times x plus 2. Because this is an equation, I'm allowed to multiply both sides by my LCD. On the left-hand side, I'll get x minus 2 times x plus 2 over 1 times 1 over 1 minus 3 over x minus 2 equals, here I think it'll be convenient to write the negative sign in the numerator. And now, noting this subtraction, I'll need to distribute. So on the left-hand side, I'll have x minus 2 times x plus 2 times 1 over 1 minus 3 times x minus 2 times x plus 2 over x minus 2 equals, on the right-hand side, negative 12 times x minus 2 times x plus 2 over, writing the denominator in factored form, x minus 2, x plus 2. Now I'm ready to see what I can cancel. I can cancel an x minus 2. Over here I can cancel an x minus 2 and an x plus 2. Noticing that I've canceled everything in the denominators, I now have the polynomial equation, x minus 2 times x plus 2 minus 3 times x plus 2 equals negative 12. To solve this polynomial equation, I'll need to multiply it out. X squared minus 4 minus 3x minus 6 equals negative 12. Combining like terms over here, x squared minus 3x minus 10 is negative 12. Adding 12 to both sides, I'll get x squared minus 3x plus 2 equals 0. Now I need to factor the left-hand side. Here I've got an x squared and a 2. I need two numbers whose sum is negative 3 and whose product is positive 2. Definitely negative 1 and negative 2 will do that for me. So here I'll have an x and a negative 1, an x and a negative 2. And so my solutions are x equals 1 or x equals 2. But wait, I'm not done. I multiplied by x minus 2 times x plus 2. And that equals 0 when x equals 2. So x equals 2 is an extraneous solution. The only real solution is x equals 1. The only solution to this equation, then, is x equals 1.